Well, greetings, Mr. Kolazar's class. We're going to look into video 2 on rates of reactions. Now, our rates of reactions, how fast, are going to depend on concentration, surface area, pressure, temperature, presence of catalyst, and one we won't talk about too much, but another one that's included, nature of reactants. Ionic usually react faster than covalent because there's usually fewer bonds to break. That'll just be a side note. So our first one we're going to look at, concentration. By increasing the concentration of reactants, we get more collisions occurring. So the more collisions we have, the more chance we have of getting an actual reaction to occur. So this will increase the rate of reaction. You know, the idea would be if you only have a few reactants, for those two to bounce into each other correctly, correct orientation, isn't going to be as often as if we have a bunch of products or reactants occurring where we get a chance for a lot more collisions to occur. If we were to think about the amusement park, bumper cars, a lot more collisions would be occurring here. Our second one is going to be to increase surface area. Again, the idea is more chances for collisions. If we increase the surface area, so let's say we had one block of a substance and the red dots have to come in and attach. If we were to break that substance into smaller pieces, those reds are allowed to attach and connect to the greens much quicker and faster. So if we were to have, say, a block of material instead, so if we have a chunk of steel versus steel wool, this one's going to be much slower in reacting, spread apart a lot more. It's going to be a much faster reaction because we have the reactants able to contact each other much quicker and much more. Pressure, increasing pressure, so a decrease in volume is going to allow us to have more collisions. This is only for gases. So for our gases, we can use pressure, and by changing the volume of our container, if we shrink that, we increase the rate of reaction because we get more collisions. So anytime we can get more collisions, we have a chance of getting more reactions, only again with gases. Temperature, if we have temperature, the more temperature, the faster they're moving the particles. If we are too cold, slow going, that reaction's not going to occur. The overlapping of those electron orbitals doesn't happen. They repel each other, and the molecules just bounce off of each other. So if the temperature is too cold, not going to react. If it's a little bit warmer, they're going to move a little bit faster. It's going to take a little bit of time, but eventually they will react. And if it's a much higher temperature, they're moving very fast. Those collisions can happen very quickly, and we get that reaction to occur right away. So higher temperature, faster moving, more effective collisions, and more energy gets that rate of reaction to increase. And our last one, presence of a catalyst. Catalysts are going to lower the activation energy. Question mark about why that is. That's going to be coming up in another section or two. They take part in the reaction, but they are unchanged. So in the end, this catalyst is going to be back as it was at the beginning. So they're used a lot of time in biological places, and so we'll be discussing that, and especially in the human body. But the catalyst brings our two reactants together, and as it brings those two reactants together, it allows that activation complex to form. Afterwards, our catalyst is back as it was before, so it's remained unchanged, and we have our new products produced. So those are the different ways to increase the rates of reactions.